is just like really, really sensitive. So today's the 22nd. We are wrapping up yesterday's lesson on the new look at parabolas. So guys, we should all have two parabolas drawn here. We should have this one that we could put through the origin. Or we should have this one, because we saw that it was 2 feet deep, 8 feet wide. So now if I look at one of those parabolas to start trying to figure out how I can make an equation here so that I can figure out how far the vertex is from the focus. Because we remember our equations up here on the front tell us everything that we need, which actually they're right up there too on the TV. But once I know my equation, I can easily find my focus and my focus length or focal length. But I need that equation. So if I use my red parabola, what's something you could say about it, Brian?
It's down 2, so it's going to have -2 out of the parentheses, and it's going to have thing that makes it wider.
So it's made wider and it's shifted. And we also know what would solve it, right? Like what would make my equation equal 0? What would that be? My zeros, my solution points.
2, 4, and -4.
So we have solution points of 4 and -4. So if we wanted to, we could work backwards and say, okay, x equals positive or -2. That's my solution points for when y equals 0. So I'm going to have some f of x that can be solved by either a positive 4 or a -4. So, sorry, I don't know why I wrote 2. Brian, you're stuck in my head. Positive 4, -4, not 2. We're going to end up with a -2 in my equation because we've got that vertical shift. So if I start thinking about, well, has a horizontal shift been done? So no horizontal shift's been done, and vertical shift has been done, and it's been made wider. So here's the misconception that a lot of people want to start with. They say, okay, well, there's been no horizontal shift, so then I'm just going to say -2. And then I'll mess with this until it works. But here's what we know. There are x values at 4 and -4 that make this 0. We literally just work backwards. If you had this as an answer when we've been working with parabolas, the step that would have come before that is a factored function that would have spit out my x minus 4 and my x plus 4. Any questions for how I went from here to there?
I'm confused on how you got the positive or -4.
Because my parabola, so we are going to use my red parabola. We could have drawn red or blue, or actually we could put it anywhere we want on the graph. But what we know is it's 8 feet wide, 2 feet deep, because that's the solar panel I'm dealing with. So I could either draw it with the bottom of it being the origin point, or the bottom of it being down negative, and the solution points or the edges being at 0. So the red one works better because I get 2 solution points, which lets me start to build a function. If I start with the blue one, it would actually be harder. Because I don't have 2 solution points, I can't build my binomials. So, if I erase this, hopefully this helps a little bit. Does that make sense where we got my positive 4 and my -4 for the x equals?
I'm still kind of confused.
So at these points, except my board is screwed up, y equals 0, so that's the solutions to my quadratic. Right, so there is a point at the function, 2 points, where y equals 0, and those solution points are positive or -4. So I can list them out as a +4 and -4. This was just shorthand. From there, working backwards, I would have gotten those solutions from factored binomials of x minus 4 and x plus 4, because this would solve with +4, and this would solve with -4, And this f of x is really 0. But I just wrote f of x first. So we get off to the side or something, say, okay, that equals 0. I'm going to orient this really fast. So go ahead, that was odd, and multiply those binomials together. And we see here, we have a difference of squares happening. So, like I over here said, don't. Difference of squares, yeah. When we're squaring, the difference of them wipes it out. So, we get x squared minus 16. But what we really want is it to be at a minus 2. And Brian also said that the parabola gets wider. What do you think we need to do that when that actually equals 0, I can do something to both sides? It doesn't change my solution points because it doesn't change my 0. And yet it makes my right side what I want it to be, right? Divide or multiply by a fraction, yeah. What do you think, guy?
I don't know. I haven't thought that much. Oh, 1/8.
I was giving him a second to think it through. I knew. So if we multiply on both sides by 1/8, I can feel it getting stronger. Then we still have 0 equals an 1/8 x squared minus 2. Now, when I plug in 4 or negative 4 for x squared gives me 16. An 1/8 of 16 is 2. 2 minus 2 equals 0. That is my function.
Okay, I'm confused why we did the 1/8. Or like where we got that.
Without applying the 1/8, you actually have a parabola that is the standard sloped parabola, like the x squared, and it has been shifted vertically down by 16. So that would actually be a parabola. I'm not quite certain how wide it would be, depending on how deep you made it. But that'd be a parabola that, if we set it up like this, would actually have these same solution points. Actually, it'd still be 8 wide because the solution points don't change. But it's actually 16 deep, and that would not work for catching solar. Like, yeah.
It'd be fine.
I mean, it'd be like 12% efficient or something like that, and you'd lose your job.
Then you just have to
But
get
if
a lot
that's
of it.
fine.
Yeah,
Just get like 300.
All right.
It'll be good.
Questions on the process that we just did?
I'm still confused about what
That's why we're going to do it a couple more times.
Like, why am I smarter than both? And, you know,
So we really
Oh,
use the depth that we knew, like the depth of 2.
because if
Because we
you
knew it had a depth of 2. Its change between the solution points and the bottom had to be 2, which meant that the vertical shift
okay.
had to be
a
2.
pyramid on top of a pyramid.
So, we're still not done. We need to then find what our focal length is, vertex, and focus.
What's a focal length?
It's the distance between. Did you watch the video from yesterday?
No.
I emailed it to you.
Did?
Well,
I don't check my email.
Other email.
Okay,
Why are you looking
I-
at email?
because you're in a professional digital world.
Professional.
If you go back up to the start slide, we have a vertical parabola. It has not been shifted horizontally. So how do we find the focus point? 1 over 4c. So if I'm doing 1 over 4c, 4 times what gives me 8? 4 times 2. Remember Calvin's last name is in there. So c, we then see equals 2. I have a
That
possessive
we then
smartboard.
see equals to.
Nice one.
No,
And
no,
then that tells me my focus is at 0, 2. So actually, it is right here.
See, that would
Or sorry, no, it's above. It is not. So this is where the middle, and that's how I misspoke yesterday. This is what happens when I don't do this for a year. This depth is 2. But my C is 2, which tells me that where my focus is at 0, 2. So although this is the middle of my parabola, we would actually need to put the solar receiver to above it. So if it actually stopped right here, if the panel stopped there, our solar receiver would actually be above it by 2 feet.
What's the solar receiver?
So if you are using a solar panel that is a parabola, it's going to reflect. Actually, I need to
It's gonna
restart that.
reflect the light back.
The solar panel is not the parabola. It's a mirrored parabola with a solar panel in the middle. We're trying to say, where should the solar panel be to catch the sun that is being reflected, so that you can have a small solar panel and catch a lot of sun. As opposed to a regular solar panel, you just catch the sun that hits you. If you use a mirror, you can funnel a lot more light into a small amount of space for a solar panel. Yeah.
Wouldn't the -2 shift it so it is in the middle?
What do you mean?
Because I put my parabola where the vertex was at 0, 0.
Yeah.
And I got my point at 0, 2. I think since you shifted it down,
What were you doing?
that would also shift
What were you doing?
the solutions.
Yeah. Where?
Yes.
0, 0.
So what's your?
My equation is the same, just without the -2.
No, when it's
yeah,
zero, you
plus the
wouldn't have
-2 then
The -2 would shift it down, which would also shift the focus down.
from the formula.
Yeah.
The formula has the K plus C.
Yeah. I forgot, even if, good catch, even if it only has a vertical shift, that's the part that I forgot, we have to switch over to here. So, because we have the vertical shift, we can't just use the focus as 0, 2. We have no horizontal shift, so still my H is still 0. So, go flip back to your front page. Because it's up on the TV. So up on your front page, it gives you these 2 for vertical. Ignore the right half. These 2 for your vertical parabolas are your cheat sheet, your functions. And these should be on, I'll check the reference sheet that you guys get, but this is stuff that you shouldn't need to memorize. These are the sort of things. So this is for the parabolas we've been working with if we're centered at the origin, if there's been no shift. This is if there's any kind of shift, and I forgot that just a vertical even takes us over here. I thought we needed both H and K, but just if there's no horizontal, it's just 0. Like your H is just 0. So now your focus point is at the horizontal shift, well, still 0 for us, and K plus C, my vertical shift, and my C value. So since my vertical shift was a -2, and my C value is a 2, my focus is actually at 0, 0. That's what I thought starting out yesterday. And I like that you pushed me to second guess and everything else, but when we started out and I gave that point as the focus, I thought that's what it was, but then I second guessed myself because that would be too easy. But this problem is just too easy.
And you can't, at that point, you couldn't prove that it was.
Trying to move the dot. So that does not help because everything else should. But yeah, so right below your feet, right there is where you want the receiver. So as they're shown, right there, in the middle of that parabola, and that's why they made the parabola that size, just so right across the top is even. I forget where that is. That's a real picture.
Are they on hinges or not? Wouldn't it not make a...
Those, they can follow, so this connecting bar across, they can, so if you imagine it like this, it can tilt to the east.
I was gonna say, because if it hinges, then there is a lot of sunlight.
Wait, what about shadows?
I do know that.
I know, but it looked like you were doing weird stuff.
Why?
So,
Yeah, but it's still blocking the sun from hitting that bottom part.
But is
because there's
There's
nothing,
no
no
mirror on
top.
Oh, okay. There's a receiver on top.
All the mirrors point at the receiver, so there's nothing to put light down there.
You have to have really that's a really good setup when you have lots of light coming in easily.
Like Arizona.
Yeah, like on the roof in Ohio, you might as well just put out panels because you're just catching all the light that you can. So we're doing the same thing, 8 wide, except now instead of being 2 deep, we're 4 deep. So walk the process again, except now, and you can either actually Calvin used where our vertex was the origin. Oh my gosh. And his came out a little bit simpler depending, but I would like you to use where your vertex is below the origin so that we can try that H plus K again.
I mean K plus C.
Yeah. Sorry, H plus K, or H plus C is over here. I need to fix this somehow.
Oh, in elementary school, we learned that if you drag onto the dot and then let go.
That works, except for I have some bad pixels. So if it catches a bad pixel, it confuses it. Because I used to do that.
Man. I hate when the comments go back. Me too. I was really people don't like this. Doesn't smell good.
Hey guys, have you solved this? Quit slacking.
What are you trying to solve for?
We are trying to write the equation to figure out where our focus is. So I'm going to copy down some of the important stuff.
Wait, what's that formula supposed to do?
That is our standard form.
Okay.
If you go to set up and the problem here is we don't yet know where our focus is or what the focus length is. So this C comes from our focus. So the first thing we have to figure out is how to build my equation and find this information.
Okay.
So now that we have a differently sloped parabola, we're assuming the focus is probably going to be in a different location. Because if the mirrors are angled differently, it's not going to reflect back up to that same point. So again, we can start building this. How do we start building this? Right?
Could you just use the same basic formula from the last one? Because zeros are still going to be negative 4 and 4, so you can
My zeros have not changed.
just change the little slope and then that.
So Michelle, when I get to that x squared minus 16 point now, what are you going to do? So we get to the point that my function is 1/4 x squared minus 4, and we got that because we had our points equal 0. This is now everything I need it to be because it's got the right shift.
So you're just trying to find the solution to that formula?
We know the solutions.
Yeah.
What we're trying to find is the focus.
Okay.
And the focus, so where your parabola is focused all relates back to the amount of curve that it has, right? The angle, the steepness, whatever you want to say. I need to find a good word for this. The more you change the curve, the more you're going to change where the focus is. So with the standard form of a parabola, focus smack dab in the middle. As I widen it, it'd go higher. As I tighten it, it'd come in because as it reflects, it changes how the angle goes. So this one, compared to our previous parabola,
this is now a tighter slope. So we would assume, compared to this focus point, that we'll be in the parabola or below that x-axis. So, how we get that? Our focus here, you refer back to your reference page or whatever you want to say. Our focus is going to be at h, k plus c. And those values come from the function. So our c comes from 1 over 4c. This, 1 over Kelvin, tells me that c here is 1. K here is -4. And h here doesn't exist.
Wait, can I ask, what is C pointing to? Is it pointing to the number in front of?
It's pointing to the fact that to get 4, it's 4 times whatever c is. So this right here, whatever, if you have 1 on top over a denominator, whatever 4 times that. So essentially we set 4 equal to 4c.
Okay.
That was equal to 4c, and we solved out to say c has to be 1.
Okay.
That makes sense? Because essentially we're going back to our parent function, but now we have even more information about our parent function because we found out there's a focus point, there's a directrix, all that stuff. Go back and watch tomorrow's video,
I will.
and then let me know what
Can I
questions
watch
still
it in
exist.
Spanish class?
No, unless he gives you permission.
Alright, I'll ask.
Plato, la professor.
Hey, yo, I watch
Would it be
No.
professor?
Plato's a philosopher.
Plato.
Plato.
Like ask, but I
Like
think
may
Plato
I.
means can I, may I.
Yeah.
Something.
Like
So,
Plato, we're all
yeah.
about now.
That means can I go to the bathroom?
I know.
If you ask him in Spanish, he's probably more likely to say yes.
What?
So from
No,
here,
From
here,
Blasphemy Hebrew.
gentlemen and ladies, since we know our focus will be hk plus c, I plug in 0, k is -4, c is 1.
ones look weird.
That one lifted up way too soon. It should connect all the way down. They just aren't as tall as they should be.
It looks like a shoe.
So my focus is 0. So actually, in this green, red parabola, my focus is way down here.
That's weird.
So here's the issue. If you were designing a solar panel like this, or a solar receiver, the green receiver could have, I don't know, a panel facing this direction and a panel facing that direction probably. The blue receiver for my red parabola would probably have to have receivers on all sides of it. Because depending on how tall this is, if you have light coming in, and it comes in like this, it has an angle of reflection, it's going to hit on top of your receiver point. So when it comes down to design and engineering, there's a lot of this thought process going into how do I design this? What sort of slope would you want in order to design your receiver a certain way? There would be a parabola where we could widen this out enough that the receiver could just be up here. Oh, come on.
We did it to beat everything. It's okay. We don't have to. Oh, ow.
So, what I'm trying to get to is there would be a design where you could have a panel receiver that was a very mild parabola or just a very mild curve that could go right up here and receive all of your light. Like once you get deep enough into the design. And they can curve glass, so that would not be that bad. Yeah.
I have two questions. One's a bit more serious, one's not.
Okay.
Serious one is, why don't they just make like a cone?
What do you mean?
Like a cone shape.
It still had points of inefficiency.
Yeah, but I feel like
Like,
this
it
thing,
would funnel the light to the bottom.
No, if it was like an upward cone.
What
Yeah,
if the
there
sun
could
was
be
setting?
a design that
Like, what if
could
the
work.
sun, like, here's the cone, and
Sure,
it just
you
hits
get
the
into-
side of it?
if
No, you get into a big argument of efficiency. Okay, move on. That's a really deep question.
My other question was, how at that point where it's all focusing, how hot do you think it is?
Oh,
That
like
was-
light a fire hot.
So you could cook popcorn.
Yes.
That'd be cool.
This is one of the
Like
one of
magnifying
the
glass
survival
panes.
tricks / advantages. Huh? Oh, okay, yeah.
It's quad.
So, yeah.
Quad.
Right. So this, if we want to actually answer the how far, we saw that distance was 1 centimeter. Because from the base of the red parabola. Now, so this is an opposite kind of question. This is projecting light outward.
Yeah.
So a bulb projects light from almost all directions. So since it's not trying to catch light, I was just trying to relate the two problems because I think it's interesting. But if you're trying to project light, you're talking about positioning your bulb like here. So when the light comes out, it reflects that way. When the light comes out here, it reflects this way. When the light comes out to here, it reflects that way. So it's always going to be pointing forward.
Can you finish your
Now.
survival tip?
In a mag light, I use a mag light flashlight, you can twist the top and
yeah.
it changes the throw, either wider or narrower. That is shifting where the bulb is. As the bulb moves forward, what do you think happens
Make
to
it
the
wider.
throw?
Why? You don't want to get
Think about if the bulb's here and it throws light out here.
It bounced back. It'd be narrow.
Huh?
What about if the light bulb was here?
That one would be.
Never mind.
Oh yeah, wait, it would bounce at a wider angle. You wouldn't have bounced at
I'm gonna leave that for you guys.
What?
Because it's fun to see if anyone goes home to find a mag light to actually play with it.
If I bring
I'm
a
a
mag
mag
light, am I allowed to
light.
bring one into school?
MAGLITE. I think it's not spelled, although it should be LAGHT. So one advantage of four eyes people
Ask me.
is your
Whoa.
glasses will focus the light.
That's
Can you
So-
dance with them?
So if you are outside near the intensity of the sun, if you find just the right way to focus your light, you can light a fire with just a normal pair of glasses. Now, it's really hard with a pair of glasses. If you have a magnifying glass, it's quite easy.
Question.
I can see my hair.
So, am I allowed to bring a mag light into school? We try that.
Yeah, I mean, I
Well, because I know
in
school's
my
like
car.
super triggered on like what you can and can't bring in. So,
No, it's a flashlight.
okay, cool. I don't know.
What if he accidentally brings in a lighter?
I don't know. I'm not in administration for a reason.
I'm not a pyro maniac.
I'm
Literally,
not-
Mr. Allen let us use lighters in his class.
Yeah, that was
Like, I
All right, we gotta finish this set of notes at least. So, when we look at a parabola, now everything that we know about it. First thing we learn to recognize, what shift has there been? Has there been a horizontal shift? Has there been a vertical shift? We know if there's a B value, there's been a horizontal. If there's a C value, there's been a vertical. Yes, I know. I'm recapping what we learned. So here, both have happened. We've got a B value and we've got a C value. However,
Whoa.
the intensity or the slope or whatever you want to say seems like it's stayed pretty standard.
Sorry.
I'm just trying to let you work it out. So, when given this, we can then try to complete the square or factor in a few different ways. Here we recognize, oh, I could actually set it up in a completing the square form if I use x minus 2 squared, which x minus 2 squared would actually be x squared minus 4 plus 4. So we have an extra 4 since we actually started with 8. People are still having issues with completing the square. So does anybody have questions on how we got from here to here?
Wait, quick question. Why did they add a -4
Thank you. So we took this and some magical thing that doesn't exist yet. Actually, I guess we'll go ahead and highlight this as well, because how they do it, it'd be easiest to do this. So they actually introduced two little magical things that we don't have to start with.
Oh, well, they cancel out. It's negative 4 and positive.
So they're saying take your first two terms and ignore the constant for a minute. Figure out based on those first two terms what your perfect square binomial could be. Or sorry, perfect square trinomial could be. So if my middle term was a minus 4x, then the third term, the constant, should be a positive 4. Because that would make it a perfect square. X minus 2 squared. However, we recognize this, I'm in green, right? This minus 4 doesn't actually exist. What we really have is a plus 8. So to turn the plus 8 into the plus 4 that we want it to be, we decide to remove 4 in order to make that happen.
Question: would you have to do that to both sides?
Hold on, let me follow their process. Yeah.
No, because they're adding a 4 to make it a perfect square, and then to compensate, they subtract 4 on the same
So,
side.
green and red,
Okay.
yeah, green and red are like canceled.
Oh, see.
Because this didn't exist to begin with, and this didn't
So they
exist to
threw
begin
in
with.
the 4.
That's why I drew these.
I got you.
The 4
The
makes
only
it more
stuff that
convenient, and
existed
the
to
negative
begin
4
with,
cancels
hold
out.
on, this will help, was that. So we had blue and purple to begin with. We added in green and added in red, but we didn't actually add in anything because they cancel each other.
Okay.
Now,
Coolio.
that works out in this situation because it works out well. Other situations, if it didn't work out as well, yes, you would have to do it to both sides. If you physically change the one side, you have to change the other side to compensate.
Coolio.
Other questions on the completeness square process? It is weird.
Shut up, Carmen. Mr. Hudson, Carmen's bullying me.
So, moving on. Moving on.
Even if she was, you
I'm
just shush him.
getting bullied here.
I feel like I'm being bullied because I can't teach.
I can't speak and they're bullying me because of it.
I prefer that you not speak. At the current time, because we have 3 minutes left. So, we then take what we know about our parabolas. But here's the thing that we didn't want to teach you all at once. When we have this parabola with 1 x² minus 4x plus 8, that 1 is telling me something. That 1 is telling me that my coefficient, which relates to that 1 over 4c, that's 1, and for that to be true, my c has to be 0.25. So what that's actually telling me is that in this function, the distance between is that c plus the... They don't restate the function again. So I'll go back a slide or 2.
Dude, you calm down.
So to find my focus, we got to go back to our equations. So our focus is going to be that h, k plus c. So we have our k value. And we have our h value.
And then they give us our C value.
Well, we found our c value because we knew our coefficient was 1.
Yeah.
So we set that equal to 1 over 4c, and c has to be 0.25. So then I plug in h is just 2, because in your function, it's x minus h. So since it's x minus 2,
that actually shifted me 2 to the right.
Oh yeah.
My K was 4, my C is 0.25. Oh, crap. They do tell it. I was missing that right there. But if you write it again, it doesn't hurt. Oh, come on. So then your directrix we find by the y equation of k minus c. Again, refer back to your function or your equations page. You will have these for the mastery. So my directrix is at the line of y equals 3.75.
Doesn't that make it like really easy though?
Having the equations, yeah, it's just knowing how to apply them. If you go into a job in engineering or like any of the fields that use this, you'll be able to refer back to those things.
Look it up.
Yeah, I mean, you normally have a reference page or like a function calculator, things like that. So really quickly, because I normally send you guys early, I wish that would have captured. So let's review our completing the square process here, because that's where people get screwed up. When we look at x squared plus 8x, if we were to make that a perfect square, it'd be x plus 4 squared. But that x plus 4 squared would be x squared plus 8x plus 16. So this is actually that plus an extra 2. Because it's 18 instead of being 16. We did not add this 2. That extra 2 is already there. Does that make sense? We didn't do that. It already exists. Because when I write it in perfect square form, my constant would have been 16. We have an extra constant of 2. So we are going to use this form to then find those other values. We've got my h, we've got my k, we can find my c because my coefficient there is 1, and we can work it all from there. Yeah.
Quick question. When to find like you know from like the y equals that.
Yeah.
We try to find our like nearest.
You're saying how we decide this number?
Yeah.
It's half of your b value.
Oh.
Always half of b value. Because think about it, when I do my outer and my inner, I double that term. Yeah.
And then you add the value that's not going.
Yeah, whatever extra or lacking, you just put in that constant that you need. So tomorrow, we'll be doing the last lesson in this chapter on circles. Graphing circles. Where you learn how you could graph a smiley face.
Oh, that was in